Hi everyone, welcome back to Dragonfly Engineering. So this week we've got a project where I am actually going to go from a prototyping molding setup, which is going to be running behind us, into a production molding setup using the new dual shot spinning platen molding machine. And what we are molding is a polypropylene substrate part with a rubber overmold on it. And with a few holes and things. I'll show you a picture here in a second. And right now, since it's a two-shot operation with the two molding machines in there, I have to mold the substrate, which is polypropylene, in one molding machine, the 35-ton over here. And then the robot that's attached to the 35-ton will pull the mold core that has the feature that defines the polypropylene substrate out of the first mold, and then hand that mold piece or core off to the green robot at the far wall. And then the green robot will drop this mold core with the polypropylene part still stuck in the cavity down into the second mold on the second molding machine, which is loaded with the rubber, like a thermoplastic rubber, so it can melt and then reflow and then solidify. And then the second molding machine basically overmolds the rubber part onto the polypropylene substrate. And then the green robot will pull that. Oh, and then the second boy molding machine then ejects the part out partially out of the core. And then the green robot will pull the part out of the mold core, pick up the mold core and give it back to the orange robot so that the orange robot can put that mold core back into the first molding machine and repeat the process. So the end result is a polypropylene substrate with rubber features that are molded on top of it. I can't really say what it's used for. It's for one of my day customers, and yeah. So anyway, but it's a pretty interesting prototyping process, but it takes forever. It takes, I think, 90 seconds to mold one of these little parts. And again, I'll show you one in a second. And effectively, the production time is just way too long. So we can't keep up with making these parts because of the 1.5 minutes it takes to make one part. With the new molding machine, we are going to do a 10 cavity mold, which is also going to be a dual mold setup, so that we will mold 10 substrates at once into 10 cavities in the mold. And then the molding machine will rotate the whole mold around, or well, the two molds will open. The molding machine will then rotate the array of parts stuck on the B side and rotate it 180 degrees to the second mold on the A side of the machine, which then will mold the rubber part over, all 10 of them at once. And then the yellow robot will pull the array of 10 parts out and then trim off the runners and things. So it should be pretty fun to do. So let's take a look at more detail of the current operation and the robot arduously slow prototyping process with aluminum molds and the slow handoff process of the mold core. All right, so we're in the clean room and we're gonna go over the setup briefly here. So orange robot and the boy 35-ton machine is the machine that molds the first substrate in this removable core right here. So you can see how I can pull this thing out of the mold by this little handle at the top. So this core is what is shuttled between the two molds. And basically the mold is a large receiver on one side with like a safety switch that tells the molding machine that this core is dropped into the mold, like so. And then over here is the profile of the A side of the polypropylene substrate part. And the reason why we're molding polypropylene as a base is kind of basically like a skeletal structure. The rubber that we're going to mold in the second molding machine over here, it has a lot of memory. So it's kind of like squishing a bunch of hot rubber bands into a mold that when you release the part, the rubber just doesn't lay flat. It kind of it deforms based on the internal stresses that were caused when you inject. So it's been my experience that if you're molding like rubber parts, that you need to overmold it onto a polypropylene substrate to create like a skeletal structure to hold the rubber in the actual final shape that you want it to be in. So What happens here is this mold closes, we mold the polypropylene skeletal substrate into this core, then the robot will grab the core out, shuttle it over here and hand the mold core off to this robot, to Green here, and then Green will drop the core into a similar receiver, and then we overmold with that feature on the A side of this molding machine, which is a 25-ton boy molding machine, the rubber overmold shape. And then ultimately the part winds up in this bucket over here. So these are finished parts. There's a rubber sprue and then a polypropylene sprue, and then these are manually trimmed offline. So let's check this operation out. All right, so we are ready to start this process up. I'll walk you through how I do it. And it involves starting the 2 robots and the 2 molding machines. So first we will go to the second molding machine and go to automatic mode and then hit the green button. And this machine is now waiting for a signal from the robot to go ahead and mold the second shot on. But first the robot needs to drop the core in and then give the signal. And over here is the green robot controller, and it is actually ready to go. So I will hit the green start button. Whoop. So let's hit the green start button on the green robot, like so, and you see the robot, I don't know if you saw it, but it got into the pounce position. So it's ready to receive the core from this robot. So this side is triggered and ready to go. So now we can come back over and close the molding machine. And I am going to actually get the orange robot ready to go. So we'll pick the program and switch it to automatic mode. This program is actually written so that it runs at 75% speed. And then we're going to turn on the output. And that's basically the amplifier drives for the robot. Now I'm going to hit start, and we'll see this robot go to its home position, like so. And then I'm going to hit the play button again, and then the robot will go to its pounce position to pull the core out of the mold, like so. So now the robot is sitting there, and it is waiting for a signal from this molding machine that the molding machine is done molding the first substrate, and that it can then grab the core out of the mold receiver and then hand it off to Green. But one thing I would like to do, since we're just starting up, is I want to purge a little bit of the polypropylene out of this hot barrel, because there's a better chance that you'll get a good first parts if you purge out some of the plastics that's been sitting there cooking for a little bit. So I'm going to go to manual mode on the molding machine, and we're going to do an auger fill. And you saw how the injection barrel, or the screw in the barrel, moved back as it was filling with plastic. And now, and still in manual mode, I'm going to squirt out the plastic. And we'll do that a couple of times. Actually, we'll back the nozzle up. Maybe you can see in there. I'm holding a GoPro. Oh yeah, you get good lighting. So I'm going to squirt more plastic out just to clear out any of the old stuff. You may not have seen much. Okay. And then we'll reach in there and we will, using some of this old polypropylene, clear out this hot plastic. Making sure that there's nothing that's going to obstruct the flow of plastic into the mold input, which is this whole little hole right there. Okay. I probably need to reset this program because it will time out if it's waiting too long. So we'll go to manual mode. I'll hit automatic mode and then the start cycle button. The robot will sit there all day long and doesn't care if it times out. Okay, so now we will go to fully automatic mode on this one. Make sure the pump is on, and I'll hit cycle start. And nothing's gonna happen because we are doing the very first cycle for the day. normally the molding machine is sitting here waiting for an input from the robot that says, I just dropped the mold core back into the mold receiver. And when it pulls out from the clear position so that the robot doesn't get crushed by the mold closing, then it'll give the signal to the molding machine that says, okay, I'm out of the way, you can go ahead and restart the cycle and mold a new part. But since this is the very first shot for the day, what I need to do is manually override that first signal that says all clear. So I'm making sure that the robot is actually not in the crush zone of the clamp. And then I will say manual release, which is another way of saying override the safety signal. So when I click this button and hit OK, the mold closes. And I need to make sure I turn that override back off. Otherwise, the molding machine may close on the robot because it will ignore the all clear signal if I don't turn that back off. Okay, so now we are molding. And you see we're cooling the part right now. The mold opens, the robot got the signal that it's clear to grab the part, and it pulls the mold core out of the mold. You see a little bit of a lift right there. And then we come over to the green robot, who then grabs, hands off the mold core, and then drops the mold core into the second mold receiver. And then you can see how it closes, and then the rubber is overmolded onto the polypropylene substrate. And here it goes through its little cycle of chilling. And then the mold opens. The green robot gets the signal after the ejection stops to come down and pull the part out of the core that was ejected. And we only eject on the second shot. And then the robot with its second claw grabs the mold core and then hands it back to the orange robot. And then over here, the robot drops the part into the bin, and then we continue the process. So that step right there where the mold closed is what I had to override for the very first shot. But now that we're in a continual operation, basically I can walk away. Oh, yeah, okay, we're still good. I was thinking I had a stuck sprue, but it was just doing its thing. Yeah, and then this will continue for the next 4 days. And back and forth. You can see some grease on the side of the kind of the way rails for that mold core to fit into the mold receiver there, like so. And there's 2 alignment pins on the core that is shuttled between the 2 molds, and those alignment pins engage some alignment bearings in the A side of the mold. You'll see how they'll pull out here when the mold opens. And the mold core is actually kind of loose in that receiving socket, and that allows the pins to find their home in the 2 alignment bearings on the A side. And you can see that there's kind of a bullet shape on those alignment pins, and they're also used for the second claw to hand off between the 2. And then it drops back in and continues. And it's sitting there ready to grab the polypropylene molded core back out again. So far we've done 984. This operation ran yesterday as well. And you can see it's, 89 seconds per part, which is excruciatingly slow. It's fun to watch these robots do this, but after about 3 days, you become sort of impatient. And you really want the thing to just be done. Hence, we need to retire this prototyping dual molding Rube Goldberg setup and come up with 2 sets of molds that will do the same thing, but instead of making 1 every 90 seconds, it will make 10 every 40 seconds. The one thing though is that with the dual mold setup that we're going to be making here shortly, we're effectively making 2 duplicate molds for the B side of the molding machine, which is basically just holding the polypropylene substrate. And you can see we're getting some wear on this aluminum prototype mold. Another thing is that switch down there tells the molding machine that the core is actually in the right spot. You may see that sometimes that mold core, it hesitates for a little bit before it drops into its receiving position. But we don't want the molding machine to think that the mold core is in the right spot and then close when those guide pins aren't lined up with the alignment pins on the A side of this mold. So that switch there is actually in line with the signal from the robot to the molding machine. And thus, well actually, and this mold receiver has the same switch. So when the robot drops the core into the mold, it releases a signal, and that signal goes through that switch. So if the switch is open because the mold core isn't seated correctly, then everything stops and the molding machine doesn't get its signal, and then the robot actually stops sending its signal. Usually the trigger signal is about maybe 1/4 of a second of 24 volts. So if that switch isn't closed by the mold core closing it, then the molding machine will never get the I'm okay signal to close the mold and continue the process. You can also see that I've got the magnetic Thor Labs kinematic mounts, but I put a safety belt on them just in case a part is stuck in the mold core and the robot is trying to tug on it too hard. The magnet release will release, but this whole end effector won't fall off and start flopping around as the robot continues to work. So I've added this safety belt so that we can kind of break contact mechanically, but then the thing will snap back into the correct place. So even if it's kind of really off, it'll go back to its home. Let me get out of here while the orange is coming in. And that's it. I think I covered everything. Anyway, but this is probably the last time we're going to run like this. And then let's take a look at the new design, which is going to be the dual mold on the rotating platen new molding machine in the back. All right, so I picked up a couple of 10-inch aluminum mold blanks, and these are basically just pre-made, all of the kind of structure of a mold. And I'm going to use aluminum with A2 steel top plates. There's a big old chunk of A2 tool steel. And I'm using these aluminum mold bases because I don't want to over fatigue the rotary table of the new molding machine. And they cost a little less, and they're really just to support the A2 tool steel. The clamping force isn't going to be very high, or doesn't need to be very high for these small little parts, even though we're doing 10 at a time. So I can just back down on the, instead of doing 250 tons of clamping force, I could probably get away with just the minimum clamping force, which may be 100 to 130 tons across both molds. So I've got some footage of opening up these molds. I had to hammer out these guide bearings. Or these guide pins. Which fit into these alignment bushings on the B side of the mold. And I ordered longer ones because I'm adding an extra inch of tool steel, 1/2 inch on each side, that we're going to basically place the inserts for all of these copies of the same part. And the inserts are going to be individually machined, and the cavities are going to be EDM milled into the tool steel. That's electric discharge machining. So we're going to machine a bunch of copper positive shapes of the cavity of the parts, and then burn in the cavities into the steel inserts using the electric discharge machine, or EDM machine. But since these are, you know, I digress. Since the steel is an extra inch that we're adding, I need to get guide pins that are 1 inch longer so that they engage correctly. Because these guide pins actually have like a structure to them. There's a press fit at the base of the pin, and then some of them have a very slight taper, but I think these just have like a 1/1000th undersize, so that we don't, you know, have a press fit going into the alignment bushings on the mold. But we do want to have a press fit at the base of the guide pin so that it seats correctly into the A side of the mold. So over the next week or two, I will show more of the process of doing the hard tool steel fabrication for this production mold, and we will retire the long and slow aluminum mold set and that the robots have to deal with all day and night. Well, it's about 8 o'clock at night, and they've been going at it all day long, unsupervised, which is always nice. So let's turn the lights on and see how they're doing in there. All right, well, looks like they're still at it. Let's see if there's still a part in that core. Yeah. So far, so good. I mean, I would have known there was a problem if I saw the flashy red light. So anyway, thanks for watching, and I will see you guys next week. I may also start showing the process of fabricating the aluminum mold set for the Game Tamer board game accessories and playing card holder and the token trays. So that'll be kind of fun. Those molds were made over the last several months, so I can start tapering in some of the build videos of those molds as well. So I will see you all later. Thanks for watching. Please like and subscribe, and if you'd like to become a patron, you can check out the information at the end of the video. Thanks a lot. See you next week. Bye.